And you might be surprised, but we'll understand this at a later point. Why is this so? So we can summarize from this that model implementation and maintenance are the arena where an ML engineer is the lone warrior and would primarily work towards extracting the solution from the data. Okay. So now we saw the DSLC or the data science life cycle. Now let's shed some more light into the day-to-day activities of an ML engineer, shall we? So let us say, like, a client has asked us that find out how much revenue we will get in the next quarter. But unfortunately or fortunately, the data you have is just transaction data, like the bill number, the bill date, the bill that you generate when you shop online or even in a store. So now what does the ML engineer do? That poor guy needs to calculate the revenue numbers by combining all such transactions. He needs to do many things to make the data suitable for our problem. And he also needs to do something very interesting. That is, he needs to capture patterns, capture some interesting patterns. And these are called features. For example, like how many festivals are there in this month? Or how many Sundays are there within this month, because that might have a direct relation to how much sales or how much revenue the customer is going to make. Now after some data operations, the ML engineer also has to find out which is the best algorithm for our model. For example, if you're looking at a forecasting solution, you need to use a time series based model. On the other hand, you might also need to use multivariate model or multivariate or multiple regression, right? For certain other cases. So it will differ from problem to problem. Now, he will also have to test his models. Now, in software development lifecycle or in the normal development work that goes on into the IT sector, we have testers and developers. So testers are separate, they test whatever is being done, the features. But in DSLC or the data science lifecycle, the ML engineer will have to create his own model and he will have to be the tester for his own models. So sometimes we also tweak the libraries. So, libraries, it's as common as in Java or C, we tweak the libraries. So we create our own sort of libraries because all the functionalities are not present within the predefined libraries. So, in fact, Srujan, I do remember you were doing that last week, right? Can you shed some light on that?
Yes, yes, yes. So let me share that. This happened last week. So what we were trying to do is, I think most of you know laws of gravity. You would have studied in your high school, in your college, in physics, laws of gravity. That if there are two bodies, they create something called as gravity, and they have an attraction between them, right? We can actually apply these laws of gravity in the retail world. So client came to us asking us, where shall I open the next store? For example, DMart or Big Bazaar or Central, right? They have to know where to open the next store. They can open in a very long place. We found some libraries online which could help us implement this laws of gravity into retail, but we were not able to use it as is. So what we did is we went inside the libraries, we copied the functions inside the libraries, we tweaked them to our customization, and we created a new library. We are also going to share that library in so that anybody could use that in the GitHub. So yeah, like we have studied in physics, now there is a library somebody made and we are tweaking that and we are creating a new library. uh, I want to add just one more point just to here is an ML engineer also need to be aware of what are the new libraries available, because sometimes new libraries come up with functionality uh, which can make your job easier. So you would have implemented something using a very old library in your client project. So you have to always look for new libraries, new versions of your library, such that you could always use the new ones, use the new features. It could be more effective sometimes too. Yeah, that's all. Thanks.
Thanks, Srujan, for that. Yeah, we do use some new, we need to be abreast of the technologies then the new, because this is open source is being used in data science every day nowadays. So, and we have a wonderful developer community who keeps on, like, creating new packages, enriching the libraries. So we need to be at tandem with that as well. Right. Now, let us take a live business problem which we have solved a few years ago. Okay. So, right. So this is a credit risk analytics case study. Now, some of you might be aware of credit risk analytics. So, our project was based on the acquisition risk mitigation for a financial organization called Credex. So, like financial organizations like banks, people go and apply loans, and the bank will have to accept or reject the loan application. Because otherwise, if you accept everyone's loan, it's a problem because client will lose money, and or even good customers. Or in other words, if your client can be facing losses because they might be giving loans to bad people or not giving loans to good people. So we will use predictive modeling to minimize the business loss scenario. So we are going to use demographic data and credit history for our case study purposes. We are also going to use, or we are also going to create strategies to mitigate some, acquisition risk and assess the financial benefits of the project. Cool. So this is the total high level approach. So, you know, yeah, just a second. Yeah, okay. So this is the bird's eye view of the approach. So when I say bird's eye view of the approach, what do I mean? You can easily look at the data, and you can easily look at the high level picture over here, and you can see that what are the steps are being taken. So we initially start with the two data sets, ideally the demographic data and the credit history data. So this will be huge for any bank, but here we will work on a dummy data so that the size will not be so humongous. So we will perform data manipulation like, missing value treatment, removal of duplicates, outlier analysis to get the data ready for exploratory data analysis and modeling. After that, we will perform exploratory data analysis, which is the univariate, multivariate, and bivariate analysis. We also use feature selection to identify which are the probable important variables for modeling exercise. And lastly, we would do some oversampling and undersampling using SMOT and go on to perform some modeling exercise like we will use logistic regression, decision tree, and random forest and choose the model with the best accuracy. Okay, right. So now let us have a brief look at the feature engineering and the EDA phase. So in the very beginning, we need to do some data processing, that is cleaning and the preparation of the data. So this includes multiple aspects like, duplicate value treatment, business rule validation, merging the data, etc., etc. So in our project, we had two such cases of business rule violation. We saw that there were some 65 records where, the credit card was issued to minors, that is people having age below 18 years. So this is highly illegal in US. And another thing that we saw was there was about 106 such records where the credit card was issued to people whose income was zero or even negative. Imagine that. So this is highly anomalous because no one in their right minds would issue credits to some people who doesn't have any income or who is having actually negative income. So, and also there was no extra info to specify this, that this is a special case you need to consider. So we went ahead and deleted these records. We also deleted some records where the application ID was duplicate. Okay, after this, we do some missing value treatment. Now, many a times, due to some error in the data collection, you know, while collecting the data or while reading the data, or even due to simple unavailability of the data, we can have missing values, missing values within our data. For example, a customer may not mention his age in the loan application. People are sometimes, oh, I won't specify my age. People are sometimes very particular about that. So we need to treat these variables, because it might impact your model. So we need to treat these variables by either deleting them or imputing them with some appropriate value. And there are multiple techniques that an analyst needs to know to do this properly. So in our project, the total percentage of missing values was roughly about 4.45%, which is significantly low, you may say. And it's true, but it can still impact the model. So what we did is we used the HMIC package. It's a very popular package which uses regression to impute the values, missing values. We used that to impute the columns that was having the missing values. Right. Now, another essential part of data cleaning is the outlier treatment. Now, outliers are simple data points which are very far from the original data points, or in other words, you can say that they are very unusual values within the data set. For example, you want to get an idea of the average salary of employees within an organization. Let us say it's around 4 to 4.5 lakhs per annum. However, if you include the salary of a CEO within this exercise, what will happen? Your average employee salary will probably shoot up to 30-35 lakhs. And this will basically distort your results, right? So in our project, we used a combination of histograms and box plots to identify the outliers. And in this screen, you can see that we have, for two variables, the number of months in current company that the customer has spent and the average credit card utilization of that customer in the last year. We have outliers present. You can see these dots in the box plot and also in the histogram, right? So there are different ways to treat the outliers, which we won't discuss today, but we are going to take it up in some other day where we will discuss this as at length. Okay, so now that we are done with missing values, outlier treatment, and duplicate analysis, a very important step remains. So many a times during our analysis, we feel the need for, some additional variables like what we already have. We feel the need for some additional variables in addition to what we have. For example, we have consider within a bank, customers have daily account balance that they are maintaining in their account. But you might feel that no, I need a variable which captures how many times his balance became zero in the last 3 months. So this is not there in the original data, right? Then if we give that to the machine learning model, it will know whether this is a risky customer or not. So primarily there are five types of derived variables. One is the time series based variables. These are variables that contain lagged variables like lagged balance of customer. That is, how much balance did the customer had last year or last week or last month, etc. Next, we have the aggregation based variables. So in aggregation based variables, we have, for example, the average customer balance or total number of times he inquired regarding his credit score, those kinds. We also have comparison based variables. So what happens is, this many times in bank, you will see privileged customers. You get emails, you can get privileged customer credit card, something like that. So all these benefits, how does a bank decide? So it's pretty simple. They take the average balance of a particular customer and they compare it with the average balance across all the customers of that bank. And if they see that he is above a certain level, he is probably above average or or above some number, they will classify him as a privileged customer. Next, we have the deviation based variables. This is a very simple variable like standard deviation of customer balance. It's going to tell you whether the like if the customer income is highly variable. Like, sometimes he gets good business, but sometimes he gets bad business. So not a stable income. So imagine in this Corona times, many business have gone down under. But as a bank, you can feel sympathy for him. You can sympathize with that businessman. But if you see his business is going down, you're not going to give him a loan. This is a business, it's not charity. And lastly, we have something called as the category based variables, or binning based variables. So here we bin the continuous variables into categories. So we had something like this in our exercise as well. We had the age variable and the salary variable. So what we did is, for better generating better understanding or generating better insights, we bin the column into specific buckets. We bin the age into young adult, adult, and senior adult, and we bin the salary into low income, mid income, and high income. So this will essentially generate better insights. Okay, right then. So now that we are done with the data cleaning part, now we move on to the exploratory data analysis phase. One of the most important phases in DSLC, and as the name suggests, here we explore the different columns within the data. We analyze them to gather certain insights and discover certain anomalies within the data. Now there are broadly three types of EDA: the univariate, the bivariate, and the multivariate. So
Jishnu, sorry to interrupt you, because
yes,
since you are going more into the detail about the data, one
yes.
question from the participant is, what is the population of the data set? How big is the data, and which market is the data from?
Okay, so the population of the data, this is a very good question. We have it, like, can we move on to the slide? Okay, I don't get access to the data set right now. So this is something around 71,000 rows and 19 columns, and 71,000 rows and 12 columns in demographic and credit bureau data, respectively. So ideally, there's a humongous data in banks, but what we do is we take a dummy data in this case, and this is from the financial sector. Does that answer your question?
Yeah, I think so. That clears. Yeah.
Okay, thanks for that question. Right. So we were discussing the EDA. So we saw that there are three types: the univariate, the bivariate, and the multivariate. So let us first look at the univariate analysis. So univariate analysis is a place where you explore or summarize one variable at a time. So you can see in here, for example, the number of male customers are significantly more than the female customers, or even the percentage of married people are way more than the unmarried people. So this basically gives you a distribution of each and every variables. Now let us look at bivariate analysis. So in bivariate analysis, you essentially explore the empirical relationship between two variables. So in this case, you can see that we have compared the education variable with the performance tag variable, which is technically signifies whether a person has defaulted or not. So we can see that if people who have not mentioned their education details, they tend to default more. So it was essentially 7.1%, and for others it was around, okay, sorry, I scrolled it too fast. So it was essentially 7.1% for people who didn't mention their education, and it was around 4.1 to 4.3% for people who mentioned their educational background. Right. Finally, if you are comparing the relationship between two or, I mean, more than two variables, it is called a multivariate analysis. So here we are comparing the relationship between salary group, that we got in the derived variable stage, the type of residence, and the default variable. So essentially, the prospects who are living in a rented house are likely to default more. Right. Phew. So we are covered with the EDA as well. But the ML engineer need not work on all that data analysis or EDA, because the data analyst is sufficient to do that work. And the ML engineer can simply, look at those charts and graphs to decide how to use that data or what are the problems in that data. So now the EDA is done. So a ML engineer has many features with him. So how does he decide which ones to take, or even better to say, how to create new features out of the data? So there are many techniques. One such is the WOE, or the weight of evidence. So we use WOE to understand the importance of variables. In other words, the predictive power in relation to the dependent variable. We do that and we select the most significant features for model building. So during the process of WOE, we use the IV, or the information variance, to select the features from a host of features. So here, I mean, I'm not going to the detail of WOE because that might take another hour itself. But in WOE, you can select some cutoff to decide which are your significant or important features. So we had selected the cutoff as 0.25, which gave us this five significant variables or strong predictors. Okay, so here you can see that these are the WOE plots for our most important features. And we can actually even gather certain insights from these plots as well. For example, if no PL trades are opened in an year, or if no inquiries were made regarding an auto loan or home loan, the chances of defaulting was very high. Similarly, if many such insights can be gathered if you torture the data more and all. So that's about WOE. You can use this to gather which variables are important. Now we shall talk about the model building and the selection phase. So this is like the bread and butter of a ML engineer. Okay, so we have landed into the promised land, the model building and selection. So once all the data processing and feature engineering is done, we need to start with the modeling. Like all the spices are ready, we need to start the cooking. So all the previous steps, in fact, can be done by a data analyst too, but essentially some parts are carried out by machine learning engineers sometimes from time to time. Now in our exercise, we have very less number of people who defaulted on loans, or basically who failed to pay the loans, because although the Credex is asking us for help with their credit risk analytics, but they still have some checks or some measures to identify which are whom to give the loan or not, whom is less risky to give the loan or not. So within our data, quite obviously, we have very few people who defaulted on loans. So but our model needs more data to learn, because we have a very common saying in data analytics: garbage in, garbage out. If your data is garbage, you will get a garbage output. So how can we do this? So we used something called as the smooth function to add some synthetic data in order to balance the data sets. Balance as in the class where there is node which have not defaulted and the class which had defaulted. So now we have more data for our models, and as a result, the model is a happy person now. So we choose quite a few model building techniques. We went through quite a few rounds of model building techniques, and we finally shortlisted three algorithms, namely the logistic regression, the decision tree, and the random forest. So we split the data into tra- uh, train and test, to avoid overfitting, so that your model learns the data, it doesn't memorizes the data. We used 80-20 split for the logistic regression and the 70-30 split for the decision trees and random forest. We played with the splitting criteria a bit and we decided on this one. So once the models were built, we did a model comparison to choose the best model. Okay, right then. So now in model comparison phase, we use the various kinds of evaluation metrics to decipher, like, which is the best performing model. So in our case, we had used three metrics, essentially the sensitivity, specificity, and accuracy to compare the models. That which one is faring better. So there's no need to be scared of these terms. Might have heard in the news in recent times that corona vaccine testing, the specificity of the vaccine that was being tested in Oxford had a specificity of X, or the sensitivity of the Chinese vaccine trials was Y. So these are measures, these are nothing but measures to gauge the model performance. So there are a lot of such metrics like confusion metrics, ROC, AUC, thresholding, log loss, which we shall discuss at length in our courses. So we can see in here that the random forest emerges out to be the best model amongst the three based on the evaluation metrics. You can see the green color in all. So the random forest is the clear winner. Okay, now we move on to the next step. This is a very important step in model building. It's intimidating sometimes, but it's very important. So once we get the initial results, we try to improve upon this by tweaking the model parameters. So these model parameters, they're different for different algorithms. So here, since I selected random forest as my model, I tried to further tweak some parameters and get some or attain some higher accuracy from the model than earlier. As you can see in this case, there are n parameters that can be tweaked to find the optimal value which leads to better model performance. So maybe the number of trees that you have selected in the random forest can be changed to get higher accuracy, or we can use a technique called the grid search algorithm to pass, various scenarios, and accordingly we can get a optimal parameter value. So this is also a part of model maintenance, uh, and we can look into that in detail. So this is a very important job in the financial sector, especially in the credit card companies, share market companies. We'll get into this in detail in the next one as well. So yeah, so this summarizes the model parameters and the tuning. So in the end, after looking at the model comparison results and tuning the model parameters, we decided on choosing random forest as our final model for both the demographic and combined data. So now we are going to use something called as the ROC curve for both the data to find the AUC, or the area under the curve values for them. So looking at the figures, we can safely conclude that the model on combined data has a better chance of distinguishing between positive and negative class, because it has a better AUC value than the other model. Or in other words, we can also say that the both the credit bureau data and demographic data, if we use it to build the model, we can have a higher chances of reducing credit loss and revenue loss, because we are going to capture more people who are going to default, and thereby we can say that no, you're not going to be given the loan. So we can cut down our losses. So with this, our model is done and dusted, and it's ready for deployment. So you can go ahead, deploy this. But after this comes the model maintenance part. So model maintenance is a very, very important job in every project, especially as I said in financial organizations, because there are multiple number of regulations that are present in the financial sector. And the ML product needs to work as expected post the delivery. So, as an ML engineer, you have enormous weight on your shoulders, because you need to look at the model metrics like ROC, AUC, hyperparameters to ensure that the quality of the product is not hindered in any way. And also, with the advent of big data, nowadays new data is getting added each and every day. And forget day, each and every second. So a statistics was something like 400 hours of video are being uploaded into the YouTube every second nowadays. Imagine 400 hours. So like that, every day we are getting new data. And so with the advent of new data, or when new data is being added, the ML engineer needs to ensure that the model behaves properly. That is, with the addition of new data, your model should not go ahead and violate certain regulations, because it may mean that the models that were working earlier, that were working fine earlier, now it may cease to work. For example, earlier you had used a decision tree, but now you need to use a random forest because decision tree became redundant. Or you might need to use some neural network because random forest is not able to handle that. And lastly, in maintenance, you also need to take care of the libraries. So, data science mostly uses open source languages like Python, R, and all. So, in Python and R, we have a wonderful developer community. So the packages which you used earlier might have a better alternative now, or it might have been upgraded, and some codes may now just stop to work. So what do? You can't just say no, I have delivered, I won't look into this anymore. So an ML engineer might have to go ahead and incorporate changes to ensure that the execution remains smooth and correct. Right. So with that, we come to the end of our model building and deployment process.